Our next section that we're going to talk about and look at today is this thing called percent composition. Now, percent means out of 100. So percent composition, we're just finding what is the percent of each element in the compound. So to find the percent composition of the following compounds, we're going to look at a couple examples. So our first compound that we have is lithium phosphate. So the first thing that we need to do is figure out what is the actual mass of the compound. So we've been doing that with our mole conversions again. So break it up into our different elements. So we have lithium, phosphorus, and oxygen. Looking at the chemical formula, we have 3 atoms of lithium, 1 atom of phosphorus, and 4 atoms of oxygen. Then we multiply by the respective mass of each one. So lithium has a mass of 6.94 grams. Phosphorus is 30.97 grams. And oxygen is, of course, 16 grams. So we're going to calculate that out real quickly. 3 times 6.94, 20.82 grams, then 30.97 grams, that should be 64 grams. And once we've done that, we add up all of it to get the total mass. So 20.82 plus 30.97 plus 64, and come up with mass of 115.79 grams for the total mass. Okay, so find the percent composition of each element. So let's first look at percent of lithium. What we do is we take the mass that the element has in the compound. So for lithium, it has total mass of 20.82 grams. Then we're going to divide by the mass of the compound. Now, since it is percent, we got to multiply by 100. 20.82 divided by 115.79. Multiply by that by 100. And what I'm doing is I'm coming up with a percent of 17.98%. Okay, next one, percent of phosphorus. 30.97 grams over 115.79 grams times 100. 30.97 divided by 115.79, multiply by 100, and we're coming up with 26.75% oxygen. Okay, we're going to take 64 grams over 115.79 grams, multiply by 100. 64 divided by 115.79 times 100. And 55.27. So one of the things that we can possibly do to kind of see if we are on track is we can add up the different percentages from each of the elements and see what we come up with. Now, since with rounding, we might be a little bit under, we might be a little bit over 100, but if we're very, very, very close to 100, then we should be fine. 17.98 plus 26.75 plus 55.27. Adding up all those numbers, we have 100. So those percents equals up to 100%, and that's how we do percent composition for our first compound. Now let's do 2 more examples. Our next one is going to be ammonium carbonate and chromium arsenate. Chromium 2 arsenate. So once again, just like what we did with our first one, we first need to figure out what is the total mass on the compound. For our next example, we have 4 different types of elements. We have 2 atoms of nitrogen, 8 atoms of hydrogen, 1 atom of carbon, and 3 of oxygen. Okay, and then we're going to multiply by each of the respective masses. Nitrogen has a mass of 14.01 grams. So that's 28.02 grams. Hydrogen, 1.01 grams. 8.08. Carbon, 12.01. And oxygen, once again, is 16. So now we're going to add them up. 10, 11, then 16, 24, 26, 5, 7, 9. So ammonium carbonate should have a mass of 96.11. Now let's kind of check my math just to make sure that I did do this correctly. 28.02 plus 8.08 plus 12.01 plus 48, 96.11. So just like what we did before, we're going to figure out the percent of each element within the compound. So we have percent nitrogen, percent hydrogen, percent carbon, percent oxygen. So 28.02 divided by 96.11 times 100, 8.08 over 96.11 times 100, 12.01, 96.1 times 100, 48 over 96.11 times 100. Alright, so 28.02 divided by 96.11. Then multiply that by 100, that will give us 29.15%. 8.08 divided by 96.11. That'll give us 8.41% for hydrogen. Carbon, 12.01 divided by 96.11. That'll give us right around 12.5%. And oxygen, 48 divided by 96.11. That'll be right around 49.94%. And just to do one more for good measure for you for this video, figuring out percent composition of our last compound. So we have 3 elements. We have chromium, we have arsenic, and we have oxygen. We have 3 chromiums, we have 2 arsenics, and we have 8 oxygens. Now, mass of chromium on the periodic table, 51.996, so we're just going to say it's 52. Arsenic, 74.92. And oxygen, once again, is 16. Alright, so 3 times 52. 156. 2 times 74.92 for arsenic. 149.84. And oxygen, 8 times 16. 128. Alright, so adding all these up, 0.84. 15, 3, 2, 11, 13, 4. So, just doing off the top of my head, I'm coming up with 144.84 grams. Let me check this. 156 plus 149.84 plus 128, 433.84. So percent chromium, 156 grams over 433.84 grams times 100. Percent of arsenic, 149.84 grams over 433. Sorry, I'm having this in view. Grams times 100. And percent oxygen, 128 over 433.84 grams times 100. So if we run this through our calculator, 156 divided by 433.84 times 100, 35.96%. If I can make the percent sign. Arsenic, 149.84 divided by 433.84. 34.54%. And oxygen, 128 divided by 433.84. 29.50%. Okay, so hopefully you're coming up close to the same numbers that I am. And that's how you do percent composition for the first part. Now what we can possibly do, if we're given the percent composition, we can find the formulas of the compound. And we actually have two different types of formulas that we can find. One of them is called the empirical formula. And it's the chemical formula with the lowest whole number ratio of atoms for each element in the compound. And the molecular formula, to put it real simply, it's just the actual chemical formula of the compound. And let's look at two examples of finding either just the empirical formula or the empirical and the molecular formula. So our first one, ascorbic acid, which is vitamin C, contains 40.92% carbon, 4.58% hydrogen, and 54.50% oxygen by mass. And then what we're going to do is we're going to find the empirical formula of ascorbic acid. For this type of problem, the first thing that we need to do is we need to convert from percents to mass. Now how do we do that? Well, if we look at the problem, we're given all the percents and they are by mass. So what we can do is we can assume that we have a 100-gram sample. So if we make that assumption, we can say that instead of having 40.92% carbon, we have 40.92 grams of carbon. We have 4.58 grams of hydrogen and 54.50 grams of oxygen. So after we do that, the next step in the process is we need to figure out how many moles of each element we have. So we're going to divide each of them by their respective mass. Alright, so the mass of carbon, 12.01 grams. Hydrogen, 1.01 grams. Oxygen, 16 grams. Now, if you're asking where in the world am I coming up with these numbers, these are on the periodic table. They are the masses of each individual element. So for carbon, we're going to take 40.92 grams divided by 12.01 grams. And we're going to come up with 3.41 moles. Hydrogen, 4.58 grams divided by 1.01 grams. Coming up with 4.53 moles. Oxygen, 54.50 divided by 16. We got 3.41 moles. Next step is we need to divide by the smallest number of moles. Well, if we look, we have 3.41 moles 4.53 moles, 3.41 moles. So our smallest number of moles is 3.41. We're going to divide each of them by 3.41 moles. And when we do this, we're hoping that either we get nice whole numbers like what we did with for carbon and oxygen, or we're really, really close. Now what I mean is, if we come up with 0.7, 0.8, or 0.9, usually we can just round up to the next whole number. Or if we come up with 0.1 or 0.01, we can round down to the whole number. 4.53 divided by 3.41. And we come up with 1.33. Okay, now when we come up with a decimal like this, 0.33, we can't really round down, but we still need to get rid of it. And the way that we get rid of it is we multiply by a certain number so we can get to the next whole number. So what we do is we multiply by 3. So if we take 1.33 times 3, that gives us 3.99. 3.99 is basically saying 4. Now, what we did to oxygen, since we multiply by 3, we also have to do that to the carbon and to the oxygen. So 1 times 3 is 3, 1 times 3 is 3. And once we have whole numbers, we can figure out what our formula is going to be. Okay, so the empirical formula will be C3H4O3. Okay, now let's look at our second example. Second example says cyclohexane, commonly used organic solvent, is 85.6% carbon and 14.4% hydrogen by mass, with a molar mass of 84.2 grams per mole. We need to determine the empirical and the molecular formula. So what we're going to do first is find the empirical formula like what we did with this first problem up here with ascorbic acid. We are going to assume we have a 100 gram sample just because it gives us the percents by mass. So we can say that we have 85.6 grams of carbon and 14.4 grams of hydrogen. And just like before, what we're going to do is we're going to divide each of them by their respective mass so we can figure out how many moles we have of each element. So 85.6 divided by 12.01. We have 17.13 moles of carbon, 14.4 divided by 1.01, and we have 14.26 moles of hydrogen. Then the next thing is, like what we did up with the first example, we're going to divide by the smallest number of moles. Well, our smallest number of moles is going to be the 7.13. So divide each of them by 7.13 moles. 7.13 moles. And that should give us 2. So let's check just to make sure. 14.26 divided by 7.13. Lo and behold, it does give us 2. So we have whole numbers. We can say that our empirical formula is CH2. Now we're going to figure out our molecular formula. And the way that we're going to do that is, we're given the molar mass of the compound as 84.2 grams per mole. We're going to see how many times the mass of the empirical formula, so CH2, will fit into the molar mass of the compound. So the mass of the empirical formula, carbon and hydrogen, 1 carbon, so 12.01 grams. 12.01 grams, we have 2 hydrogen, so 2 times 1.1 grams. 2.02 grams. Add that up, 14.03 grams. So now we need to see how many times 14.03 grams will fit into 84.2 grams per mole. 84.2 grams over 14.03 grams. 84.2 divided by 14.03. I'm coming up with 6.001. So this is telling me that the empirical formula mass will fit into the molar mass 6 times. So for the molecular formula, what we're going to do is we're going to take 6 times the empirical formula. So 6 times CH2. That'll come out to be, well, 6 times 1 for carbon, so C6. 6 times 2 for hydrogen, 12. So our molecular formula is C6H2. Now what I'm going to be doing for the other videos for this week is kind of just review of doing these types of problems. If you have any questions, please email me, let me know, and I will talk to you later. Thank you.